Okay, so let's continue on here to example 4 on page 33, graphing a line segment. So we have some parametric equations here. X is equal to 3t and y is equal to 2 minus 2t over a t interval of 0 to 1. And what we're going to do is we're going to identify the linear equation that would represent the graph of this parametric curve. So first thing we are going to do, if I'm looking for a linear equation, that means I want something in terms of just x is equal to, or y is equal to some function of x. So I am going to begin by solving for t in terms of x. So I'm going to take this first equation, x equals 3t, and I'm going to solve that for t. So simply divide out the 3 from each side, so t is equal to x divided by 3. And then I'm just going to, for step 2, I'm going to go to my second equation, and I'm going to substitute that t value in, and I'm going to get an equation that is now in terms of just x and y. So if I start with that equation, y is equal to 2 minus 2 times t, and I replace t with our x divided by 3 value from step 1, and we do a little bit of simplification here, we get y is equal to 2 minus 2/3 x. So let's graph our parametric equations there. X equals 3t and y is equal to 2 minus 2t. And let's see if we get something that looks like a portion of the line segment of 2 minus 2/3 x, or negative 2/3 x plus 2. So again, x equals 3t and y is equal to 2 minus 2t. So here we go, we are going to graph a parametric where x is equal to 3t and y is equal to 2 minus 2t. And our t interval, remember, was from 0 to 1. So let's get rid of that 2 pi and go from 0 to 1. Alright, let's graph that. Okay, here we go. I'll drag the equations off. So we said what we should get would be a line segment that was the graph of negative 2/3 x plus 2. Well, here we go. Y-intercept of 2, slope of negative 2/3. So we have now just verified graphically what algebraically we sort of confirmed or derived from the information we were given. Okay, next thing we want to do is we want to substitute to find the initial and the terminal points. So remember, initial point is just when we put in our left endpoint. So we're going to put 0 in for t. Well, if x is equal to 3 times t, x is going to be 0. And y is going to equal 2 minus 2 times 0, so y is going to equal 2. So our initial point is going to be 0, 2. And then our terminal point is what we get when we substitute in our right endpoint. So let's put t equals 1 in here. So x equals 3t, so x is going to equal 3. And y is going to equal 2 minus 2 times 1. So our terminal point is going to be 3, 0. Okay, and here is our final example for the segment. We are going to parametrize a line segment. So this time we know the endpoints, or we know the initial and the terminal points, and we're going to try to work backwards and get ourselves the parametric equations. And in example 4, we did the opposite of this. We had the parametric equations, we derived the linear equation, and we found the initial and the terminal points. And here we're going to go backwards. We're going to know the initial and the terminal points. And when we do this, we always assume that we have a t interval of 0 to 1. So we're trying to write these parametric equations, these x of t equations and y of t equations. So here's kind of the general form for these parametric equations. X of t is equal to the initial value plus some a value times t, and that's kind of like the slope of these lines. And then y of t looks very similar. It's the initial y plus some sort of slope value times t for the y equation. So let's take a look at our x equation. X of t is going to equal the first x value, or x sub 0, plus a times t. Well, we have this information we can sub in. We know the initial x value is right here because this is our initial point, -2. So we're going to substitute that -2 in here. And then we also have a second x value when t is equal to 1. And that happens right here. We know that when t is equal to 1, because this is the terminal point, and our terminal point comes from the upper end of our interval, so we know that when t equals 1, x is equal to 3. So x of t we're going to replace with the 3 is equal to, here's our initial x, -2, plus we're trying to solve for this a value, times t, well t was 1, that's how we generated that 3. So let's just do a little bit of algebra and clean that up. And we're going to get a is equal to 5. So that means the parametric equation is going to be x of t is equal to, we go back to this general equation, x of t is equal to our initial x value, which is -2, plus our a value, which we just said was 5, times t. So there is our x parametric equation. And we're going to use a very similar format here to find our y parametric equation. So y of t is equal to y0 plus we're going to be trying to solve for this b value times t. So our y0, we know our y0, our initial point of our y value of the initial point is 1. So we're going to be substituting 1 in here for y0. And then we have a y of t value from our second equation. We know when t is equal to 1, y is equal to 5. So y of t is going to be 5 plus b times 1 because that's our t value. So 5 equals our initial y of 1 plus b, which is what we're looking for, times t is equal to 1. So again, let's do some algebra, and we're going to get that b is equal to 4. So going back to sort of our general equation here, y of t is going to equal 1 plus 4t. And there we have sort of gone backwards from our initial and our terminal points to creating the parametric equations that would give us that graph. So let's graph it to verify. And if you want to go ahead and throw those into your Inspire and graph for yourself, you can. I've already done that. And here you can see that I'm not making it up. Here are actually the functions. Here's our -2 plus 5t and our 1 plus 4t. And indeed, we get a line segment with an initial point of -2, 1 and a terminal point of 3, 5. So there we just graphed to verify what we had already figured out algebraically. Okay, so here's your homework. It says classwork/homework, but we're all at home now, so this would just be your homework. Don't forget I've asked you to do Exploration 2 on page 32, going through all those exercises with ellipses instead of circles, and that's going to go in your notebook. And then on pages 34 and 35, numbers 1 to 31, the odds, and also number 43. And please remember that this stuff is new to you, and I understand that. I'm anticipating and I'm expecting your questions, and send them to me, you know, anytime. I do check in pretty regularly, and I'll get back to you as quickly as I can. But please don't get too frustrated. Keep in mind that it's new, and we're going to work through it together. Okay, so good luck with this. Give me a holler, ask for some help if you need it, and I'll see you back here for section 1-5.